Welcome to the Deep Dive, where we break down complex industry challenges into, well, strategic knowledge you can actually use.
And today, we're looking at a huge one.
We really are. We're staring down the barrel of a multi-billion-dollar headache, mechanical failure in critical infrastructure. We're talking about that sinking feeling a plant manager gets.
Oh, yeah.
When they realize the pump or the specialized valve or the control module that just failed is obsolete. The OEM, the original equipment manufacturer, they just stopped making it years ago.
And if you're in an industry like oil and gas, utilities, petrochemicals, or any kind of heavy manufacturing, that obsolete part, it's not just a piece of metal anymore. It's a ticking clock.
Right.
And it's counting down the hours to a catastrophic multi-million-dollar shutdown. That's where the real cost of being unprepared just explodes.
Exactly. That downtime is the real enemy here.
Yeah.
And that clock is ruthless. So we've been digging into this comprehensive guide from a specialist industrial procurement service. They do one thing. They manage this exact crisis. Our mission today is to unpack that entire life cycle into the almost unbelievable lengths they go to, from finding the unfindable part all the way to certifying its quality and getting it back into your operation.
And you should think of this deep dive as your complete briefing on how world-class organizations get ahead of this, how they move beyond just reacting to failures.
To actual risk management.
Just a true obsolescence risk management, exactly. It's a process that combines, relentless sourcing with some very specialized engineering and quality assurance.
Okay, so to make this tangible, let's anchor this with a specific example from the source material. We're talking about a legacy item that isn't just rare, it's totally proprietary. Imagine you need a high-pressure specialty filter. The designation is 1R-0750, filter as WT 1.5 CK tap.
Okay.
If you need that specific filter, your operation is either running smoothly or it's dead in the water. So we're going to track that hypothetical 1R-0750 through this entire process.
That is a perfect case study, because a filter like that, it's a small part, but if it fails in a high-tolerance system, the whole plant just stops. The stakes could not be higher.
All right, let's get into the journey then. When the standard supply chain just dries up, you get that fatal email saying, sorry, discontinued, that's when the specialized hunt for our 1R-0750 begins. How do they even start to locate components that are, for all practical purposes, extinct?
They activate what's essentially a parallel ecosystem. When the standard procurement channels fail, they leverage what are called proprietary vendor networks and specialized acquisition techniques. This is way, way beyond a Google search or your standard industry directory.
Proprietary networks. That sounds a little, a bit cloak and dagger, doesn't it?
It does a bit.
What does that actually mean in practical terms?
It means they have these direct, long-standing relationships with people who know where old inventory goes to die. They're often trusted sellers who specialize in niche legacy equipment. The sources call them white glove brokers. And these aren't your typical commodity traders. These are individuals who track, say, entire plant decommissioning schedules or have relationships with OEM warehouse managers who know exactly which boxes of old stock are sitting in the back of a facility in, Rotterdam or Houston.
So it's all about who you know, that network density. But they also tap into factory salvage and shutdown sales.
Yeah.
Right. That sounds like a whole different world from dealing with a high-end broker.
It's a massive difference, and it really speaks to their coverage. Tapping into OEM surplus and trusted liquidators is all about volume acquisition. When a major industrial plant shuts down, they might have years of critical spares just sitting there.
Right.
The procurement service has to be fast enough to get in and buy that inventory before it gets scrapped or just disappears into the general resale market.
And crucially, the speed of response here. It's not just a nice to have. It dictates the entire outcome.
Absolutely. The guide really emphasizes this rapid triage. An RFQ, a request for a quote for a critical part, gets acknowledged within 2 hours during business hours.
2 hours.
Think about that. 2 hours just to confirm the chase is on. And then they promise an initial sourcing plan within 24 to 48 hours. If your refinery is losing, say, $50,000 an hour, saving 2 weeks of search time by getting a plan in 2 days is a massive quantifiable saving.
That speed confirms a priority. But sometimes, this has to be the nightmare for every plant manager, the part genuinely doesn't exist anywhere. The stock is gone. The drawings are proprietary.
The shell goes cold.
Exactly. And this is where it gets really interesting. The ultimate fallback, reverse engineering.
This is where procurement stops being about logistics and becomes an engineering partnership. If the part, like our 1R-0750 filter, is physically unfindable, the service brings in engineering partners to literally reverse engineer it. They can work from a worn-out sample or even old original drawings if they can find them.
Hold on, reverse engineering sounds incredibly complex and probably prohibitively expensive. When does that cost-benefit analysis tip in favor of reverse engineering a part versus just, redesigning the whole subsystem to accept a modern available component?
That is a crucial distinction. The analysis favors reverse engineering when the certification or the reapproval of a totally new system, especially in heavily regulated spaces like nuclear or high-pressure chemical plants, is just too long or too expensive. You might spend 6 months and $1 million just recertifying a new pump housing. Reverse engineering gives you a certified form-fit-function match that avoids all that costly system reapproval.
I see. So the value isn't the cost of the part itself, it's the cost of recertification and the time to get back online.
Precisely. And this capability is even more critical for, say, control components. They specialize in sourcing legacy PLC modules, old control electronics.
Oh, that's a whole other level of complexity.
It is. Replicating a mechanical filter is hard, but it's often simpler than reverse engineering decades-old proprietary firmware. For those electronics, they'll often provide drop-in replacements or validated retrofit options. It ensures the brain of the aging machine can keep running without a full disruptive system overhaul.
So whether it's finding the last 1R-0750 filter in some warehouse in Europe or building a functional equivalent of a 1980s circuit board, the hunt is successful. But finding the part, that's only half the battle. Now comes the trust factor.
Exactly. This is the pivot point, because nobody wants to install an obsolete component they bought from some obscure liquidator.
And just cross their fingers.
And just hope it doesn't fail catastrophically under pressure. Yeah.
So how do they guarantee the quality? For a part that might be decades old, stored in who knows what conditions, or reverse engineered by a third party?
It comes down to a really rigorous multi-point quality process and an ironclad chain of documentation. Every single component, from a simple pump bearing to our specialized 1R-0750 filter, has to pass a detailed inspection, a traceability verification, and functional tests designed for that specific part's application.
Let's talk about that documentation. This is where the plant manager's liability is covered, right? We see a lot of acronyms in the sources: COCs, MTRs, serial traceability. What does that paperwork actually guarantee?
Okay, let's define the critical ones, because they are the cornerstone of any audit trail. A COC, a certificate of conformance, is the vendor's legal declaration that the part meets all the specs on the purchase order.
Got it.
An MTR, or material test report, proves the chemical and mechanical properties of the metals used. For a pressure-rated item, like our 1R-0750 filter, the MTR confirms the material's integrity. It proves it can handle the stress.
So if that filter fails because of material fatigue, the MTR is the historical evidence you'd need for any investigation or insurance claim.
Correct. The service guarantees every part comes with these, plus serial traceability data. And they deliver digital copies immediately for quality records and audits. Furthermore, the parts and all the docs can be certified to really demanding industrial standards, like API for petroleum equipment or NES, which is critical for corrosion control. These are non-negotiable stamps of compliance.
This brings up the huge issue of risk mitigation in this market. Counterfeits. If a rare part is worth a fortune, the incentive for fraud must be massive.
It's layered. Counterfeit mitigation starts with a very strict, trusted supply chain, but the inspection itself is key. They use component authentication, detailed visual and dimensional inspections, and if there's any doubt, they send samples to a lab.
For electronics, that must be even harder.
For electronics, they might use non-destructive testing, or NDT, to check for signs of tampering or relabeling.
And what about those reverse engineered parts? How do they match the original specs without the original OEM blueprints?
That's the engineering skill. They focus on what they call OEM matching. So they'll cross-reference the original OEM number against functional equivalents, perform engineering checks, and supply replacements that are guaranteed to be form-fit-function compatible.
And maybe even better than the original.
Often, yes. They can meet or even exceed the original specs because they can use modern materials or manufacturing techniques. If the original 1R-0750 was rated for 5,000 psi, the modern equivalent has to be rated for at least that, and usually more.
What about refurbished equipment? Pumps, large valves, bearings. That row can save a lot of capital. But how do you know the refurbishment is going to hold up?
The validation process for remanufactured items is very defined. For something like a pump, it undergoes dimensional checks, precision balancing to get rid of vibration risk, and then rigorous pressure and flow testing. Every refurbished item gets a final QA sign-off, and this is critical, is backed by a warranty.
The warranty is key.
That warranty provides the assurance that the client is buying reliability, not just a cheaper part.
Okay, so we've established the sourcing, and the certification is incredibly complex. But even when the part is sourced and certified, that clock is still ticking. Which brings us to the logistics challenge. The urgency is almost military grade when a plant is down.
It truly is. They run a dedicated priority response lane just for these critical downtime scenarios. We're talking expedited sourcing, immediate QA triage, so the inspection team rushes the certification, and then rush shipping.
Give me the brass tacks on that. What does rush really mean in this context?
It means same-day, door-to-door courier service, or even next flight out shipping via express carriers. They handle the coordination to have the part met at the airport and rush directly to the facility, often bypassing the standard warehouse receiving process because every single minute counts.
So if we're setting expectations, what are the realistic lead times here?
They're pretty transparent about it. If the part is in their physical stock, it's a same-day shipment. If it's brokered stock found through those vendor networks we talked about, you're looking at maybe 3 to 10 days.
And for remanufacturing?
If it needs full remanufacturing or reverse engineering, the lead time is longer, but it's a manageable window of about 2 to 8 weeks. But they promise to give a very realistic ETA up front and then dedicate resources to beat it.
That sounds incredibly complex when you're dealing with global sources. If they find a part in a decommissioned factory in, say, Southeast Asia, who deals with that whole logistical and regulatory maze?
They do. They manage the entire global support process. That includes customs clearance, export compliance, classifying the goods, calculating duties, and all the international shipping logistics. For global corporations, they can even offer centralized procurement, bundling parts from all over the world into one standardized shipment.
That integration has to extend to the financial and technical side, too. You can't run a critical operation on a system that needs manual data entry.
Absolutely not. The whole goal is to make this specialized service feel like just another standardized vendor. They offer financial flexibility, net 30, net 60 payment terms, even customized terms.
A quick note on that net 60 terms. That's a really strategic insight, isn't it? If you're in the middle of an unplanned outage, cash flow is critical. Extending payment terms gives you breathing room.
It's a vital move. It gives the client time to get the plant back online and making money before the bill for the replacement part is even due. And beyond that, they support the technical workflow, integrating with major ERP systems like SAP or Oracle using EDO.
So the goal is to make this niche service look like just another vendor in the SAP system.
The goal is seamless integration. They use technologies like EDIs so that purchase orders, confirmations, invoices, it all just flows automatically between their system and the client's ERP. No data entry errors, and it speeds up the whole financial cycle. It proves that even emergency purchasing can be audited and controlled.
Okay, we spent a lot of time on reactive procurement, finding the part after it fails, but now we get to shift to the truly strategic play. Proactive risk management. What does that look like?
It means moving entirely upstream. They offer these comprehensive life cycle strategies that actually anticipate failure. So they'll actively monitor OEM advisories and market signals to give clients obsolescence notifications. A heads up that a critical component, maybe the whole class of our 1R-0750 filter, is about to disappear from the market.
So you can plan for it.
It lets you buy proactively or start a redesign process on your own timeline, not under the gun.
And before you can plan, you have to know what risks you're even running. The service offers inventory health checks and bill of materials BOM audits.
And these audits are invaluable. They don't just count parts. They identify every single component that's approaching its end-of-life risk. They highlight critical spares gaps, and they give you a clear, prioritized action plan. It turns a huge, disorganized inventory list into a prioritized risk register.
So you know exactly where your vulnerabilities are.
Exactly, across all your sites.
Let's talk about on-site support, too. Managing spares inventory is a huge cost sink for corporations.
That's where vendor-managed inventory, or VMI, comes in. They'll manage consignment or VMI programs where they keep critical spares on-site or nearby, but the vendor still owns them until they're pulled for use.
And that cuts down the carrying costs for the customer.
Massively. It reduces inventory carrying costs, insurance, warehousing, all while making sure that pre-certified parts are ready to go based on forecasted usage.
And for planned shutdowns, where every minute is scheduled for maximum efficiency, they even handle customized kitting.
Kitting is vital for efficiency. They build and deliver these complete kitted assemblies tailored to the shutdown schedule. So parts, consumables, gaskets, everything for a specific job.
All in one box?
All in one box, labeled, documented, and ready to install. Your maintenance crews aren't wasting hours hunting down some obscure fastener or trying to match serial numbers for that 1R-0750 filter replacement. It's just grab and go.
Plus, long-term storage of these expensive rare spares needs to be handled professionally.
It really does. They provide packaging that's specifically designed for long-term warehousing, using things like vacuum sealing, nitrogen purging, desiccants, protective coatings. It ensures that when you finally pull that part years later, its shelf life hasn't expired.
And finally, we come back to the human element, the support needed when the part actually shows up and the crew needs to install it right now.
Right. They back all their parts with technical guidance, installation checklists, even access to on-call engineers for troubleshooting. They can also provide targeted training for the maintenance crew to make sure that rare part gets installed correctly the first time. It really closes the loop. Finding the part is useless if the team can't install it right.
This deep dive has revealed that procuring obsolete industrial parts it's so much more than just a purchasing exercise. It's a high-stakes, specialized partnership of risk management and engineering. The value proposition combines those deep industry connections, the engineering expertise, the ability to literally rebuild our 1R-0750 filter if they have to, and just relentless urgency. That all translates directly into validated parts, faster finds, and dramatically lower downtime costs.
And if we connect that to the bigger picture, the traditional view of MRO maintenance, repair, and operations is that it's just a cost center. It's reactive, it's unpredictable. But if obsolete parts can be managed strategically with services like VMI and lifecycle planning to actually reduce your MRO spend and boost reliability, well, that raises an important question for you to consider.
What's that?
What other traditionally reactive, expense-heavy functions in your organization could be converted into long-term strategic assets that actively reduce financial risk?